All right, guys. We are starting a new unit today, Unit 9. I've kind of made these last two units short, so it'll be kind of quick. We'll go through Unit 9 in about 2 weeks, and then we'll do Unit 10 in 2 weeks, and we'll be done. So we're getting there. So this unit is all about circles and different properties of circles. So you're going to have to still remember the formulas from last unit about circumference of a circle and area of a circle, because those are going to be applied throughout this unit as we go through. Today, though, we're starting with talking about some new vocabulary. So the first thing we're going to talk about is what is a central angle of a circle. And a central angle is an angle whose vertex, remember vertex, that's just the corner of your arc, is the center of the circle. So in this picture, angle ABC is a central angle. So right here, angle ABC, that's considered a central angle because this point B right here is the center of our circle. So as long as that vertex is at the center, that is considered a central angle, okay? That central angle then forms another vocabulary word, which is called a minor arc. So I'll use a different color here for minor arc. So in this picture, the minor arc would be that little arc right there, AC, okay? So that's formed on the inside right off of that central angle, okay? The points that are not on that pink minor arc, and I'll use a different color here, will be on this green part, which is called the major arc. So the major arc was the green part, the minor arc was that red part. Okay, so a semicircle is just another vocabulary word here. Semicircle are endpoints of the diameter, and it's exactly half of a circle. That's what the word semi means, that it's exactly half of a circle, right? So you'll be able to see that on some of these examples. All right, so notation. How do we write these? There's always symbols in geometry, right, for things. So when we're talking about that minor arc, right, that was this minor arc right here from A to C, we write just the two endpoints of the arc, and then we put a little arc symbol on top of it. The measure of that minor arc is equal to the central angle. So for example, let's say this central angle, I don't know, was 50 degrees. Then the measure of that arc would also be 50 degrees. They're going to be exactly the same. So the arc matches that angle. When we're talking about the major arc, which is around the other side, the way we would write that, notice there was this point over here, D. So it goes from A through D and then down to C. So we call that major arc ADC, and we use 3 letters to show that it's going through 3 points. The measure of that major arc is 360 degrees, because that's how much is total in a whole circle, minus the central angle. So for this example, if that central angle is 50, we would do 360 minus 50, and we get 310. So this over here would be 310 degrees. So that the total circle would equal 360. Okay, so this is more about measuring them, which is what we talked about. So the measure of the minor arc is the measure of the central angle. So in this example, they said that this central angle was 70, which that means that this minor arc, AC, is also 70. Those have to match. And therefore the big guy, the major arc over here, ADC, is going to be 360 minus that 70, so we'll have 290 over here. Okay, so let's practice with some symbols and naming on the next page. So go ahead and turn to page 2. And here's an example. It gives us a circle with some arcs already labeled, and then you're supposed to find, the measure of each of these arcs. So if this is 28, then we know its minor arc there, MN, is going to be the same. So that's just 28. Now it goes down to NMP. So let's think, I'll use a different color here. NMP P. Oh, well, that's exactly across half of the circle. So that's a semicircle, or half of the circle. And if the whole circle is 360 degrees, then I just divide that by 2 to get half of a circle, and that's going to be 180. So that's always 180 for any semicircle. Any semicircle, always 180. All right, let's try the next one. Measure of MP. All right, so let's find where MP is. Oh, it's just from here to here. Well, if I knew the whole big orange one was 180 and this little blue one was 28, I'm just going to do 180 minus 28, and I'll get 152. All right, let's try on the other ones now. So the next one asks for O to P, so always trace it out. If this is 73, that's going to match. The minor arc and central angle are always the same. Next one it asked for was ONP. All right, so that means I have to go in this order. O, then N, then P. So I have to start at O, then go to N, then keep going to P. So that's all of, see that dark blue area that I just highlighted. O to N to P. Well, that's basically everything except for this one section right here. So that's the whole circle minus the 73 degrees for that pink arc right there. So 360 minus 73 is 287 degrees. All right, and then our last one for this question asks for ON. So ON is just this section right here. So what do we know? We know that this is a semicircle all the way from NOP, so that's 180. So I would do 180 minus 73, which was this pink part right here. So that'll give me this green part that's remaining, and I would get 107. Okay, the arc addition postulate just says if you've got two arcs that are next to each other, you can add them together. So for example, I've got arc AB right here, and right next to it, I've got arc BC. So if I wanted to, I could add those two together, and I would get the big arc ABC. So that would make sense, right? Like if this one was 20 and this was 60, and I added both of them together, the big arc would be 80, just like we would do with segments and other things. So I think that makes sense to you guys. Okay, so now it's your turn. You're gonna do number 2, and the answers are all online. You can check them. And number 3. So you're gonna finish page 2 and then submit that online when you're done. Submit it on Schoology.